Welcome to the Non-Destructive Testing and Evaluation course video lecture. And the code for non-destructive is ME8097. And in this video session, we will be studying about the third unit of non-destructive testing and evaluation, Introduction to Infrared Thermography. So before going in depth into the third unit, we'll just go through the syllabus. We'll be studying here about the two types of non-destructive testing and evaluation, that is thermography and eddy current testing. So in thermography, we will be studying about the principles, the contact and non-contact inspection methods, techniques for applying liquid crystals, and advantages and limitations and applications of thermography, and the infrared radiation and infrared detectors, instrumentations and methods, and its industrial applications. In eddy current testing, we will be studying about the generation of eddy currents, properties of eddy currents, eddy current sensing elements, and the different types of probes, instrumentations, arrangements, applications, advantages, disadvantages, and interpretation and evaluation of eddy current testing. So these are all the contents which we are going to see in this video session. Introduction, history of infrared radiation, and the principle of thermography, thermographic camera, and types of thermographic camera, the construction, the working principle of thermography, and the types of thermography, and methods of thermography, and advantages, disadvantages, and applications of testing. So the introduction part, infrared thermography is an equipment, or it is a method which detects the infrared energy that the object emits, and it converts it into temperature, and the image are being displayed as a temperature distribution. So the image of the temperature distribution is called the infrared thermography, and the method is called as infrared thermography. So the history of infrared is, it was discovered by a British astronomer, Herschel, in 1800. So when dispersing sunlight using a prism, he accidentally found that there was an invisible light on the outside of the red light when increases the temperature of an object. So this is nothing but an electromagnetic wave. So the principle behind this, every object whose surface temperature is above absolute 0 degree Kelvin radiates energy at a wavelength that corresponds to its surface temperature. Utilizing our highly sensitive infrared cameras, it is possible to convert this radiated energy into thermal images of the objects and is being surveyed. So after survey findings, it has been provided through use of two different types of images. Color thermograms and control photos are provided of problem areas uncovered during the inspection. So this is a thermographic camera. This thermographic camera converts the radiated heat energy into an electrical signal, which is displayed on the monitor as a real-time heat image of the object. And this camera assigns the black color for the coolest area, and the hottest area will be indicated as a white color. So this is commonly known as FLIR. So types of thermographic camera, you have a single sensor. In this, we'll have a single sensor having a rotating mirror, and FPA In this, an array of detectors are used for providing information about the radiated point. So this is the construction of the system, and the first block is the object, and the second is the IR energy, that is the atmosphere, and the third is IR imager, which consists of the optics, IR detectors, and the electronic system, and the third is the display unit, which the image pattern is displayed on the screen monitor. So the infrared thermography. See here, you can see the person um, is being captured by the infrared camera, and the same is being displayed on the screen as a image, thermal image. So normally this infrared camera detects the infrared emitter and objects, and it transforms the amount of infrared energy into a temperature and is being displayed as a infrared image on the screen. And here you have the block diagram where the object is being scanned by the scanner of the infrared thermography, and you have a scanning unit, the condensing unit, the detection, amplification, display, etc. So types of thermography. Thermography are classified into two parts. Thermography is active thermography and passive thermography. So in active thermography, an energy source is required to produce a thermal contrast. So the detection can be occurred either hot or in the cold spot on the surface. But in the passive thermography, the inspected parts are at higher or at the lower temperature than the background. So methods of thermography, you have this conventional thermography or step heating, pulsed thermography, lock-in or modulated thermography. And here in this case, it is necessary to synchronize heating and acquisition. So advantages is, it is a non-contact type techniques. A large surface area can be scanned in no time and is being presented in visual and digital form, and the software backup for image processing and for analysis can be done, and very little skill is required for monitoring. The disadvantages for thermography is the cost of the instrument is very high. It is unable to detect the inside temperature if the medium is separated poly or a poly in material, etc. And it is very difficult even by the experienced person to interpret the result. And training and staying proficient is time consuming. So applications in electronics, the printed circuits board evaluation and troubleshooting is done by using the thermography testing. Used in mapping of semiconductor device service. It is being used in circuit board component evaluation, production type inspection of bonded structures, inspection of hybrid microcircuits, and inspection of solder joints. So diagnosis of electrical system can be done by this thermography testing, and it is being used in medical thermography, and it is being used to find the level detection, industrial roof moisture detection also. So with this we come to an end. Thank you. Have a great day.